Have you ever wondered why an apple falls to the ground when it's detached from its branch? Or why we don't go flying off into space as our planet spins? The answer to these questions and many more lies in a fundamental force of nature: gravity. Gravity, in simple terms, is the force that pulls two objects with mass towards each other. Imagine you're holding two magnets in your hands. If you try to bring them closer, you'll feel a pull. That's similar to gravity. But unlike magnets, which can repel or attract, gravity only attracts. It pulls objects together, never apart. Consider the apple falling from the tree once again. It's not just the earth pulling the apple down, but also the apple pulling the earth up. It's just that the earth is so much more massive than the apple, that the apple's pull doesn't have a noticeable effect on the earth, but it is there nonetheless. And what about us standing on this spinning earth? Why don't we fly off into space? That's gravity at work again. The earth is constantly pulling us towards its center, keeping us firmly on the ground. But how does gravity work? Well, according to Einstein's theory of general relativity, massive objects like planets and stars cause the space around them to curve. This curvature creates what we perceive as gravity. Imagine a bowling ball placed on a trampoline. The weight of the ball causes the trampoline to curve or dip. Now, if you roll a marble along the trampoline, it will move towards the bowling ball, following the curve. That's what happens in our universe. The Earth, our bowling ball, distorts the space around it, causing objects, the marbles, to move along a curved path towards it. The more massive an object is, the stronger its gravitational pull. That's why planets, with their huge mass, have enough gravity to keep moons in orbit, and why the Sun, even more massive, can keep planets like our Earth in its orbit. So, to summarize, gravity is the force of attraction that exists between any two masses, any two bodies, any two particles. It's what keeps our feet on the ground and the Earth in orbit around the Sun. It's described by Einstein's theory of general relativity, which tells us that gravity is not just a force, but a curvature of space-time around massive objects. The more massive an object is, the stronger its gravitational pull. So the next time you see an apple fall from a tree or gaze up at the moon in the night sky, remember, it's all thanks to gravity, a fundamental force that, despite its invisibility, shapes the universe and our lives in profound ways.